Alrighty. So, here. Sorry. Let me. How do I? There. Nope. Go away. Okay. So, I'm sorry. Got sidetracked. So, okay. So here's our some example. I made one called Do Math. Right now it doesn't do anything, but this is how you're going to write a function. So the important things to know are yes. Yes. Like closer up or like angle it. Both.
Right there.
Okay. So this Do Math. Sorry, I was looking around. I'm moving my table as well. So Do Math. Right now it doesn't do anything, but the important thing is to look at what's called the signature, which is the name of the function, and basically I'll call it the declaration. What it is. So the important thing to know is I made this kind of similar. So it starts out with this int, which is, remember that primitive type for number. Then I have a name that I call Do Math, and then I have the parentheses again. I'm going to show off a couple different ways to do this, but basically I can call this function and it'll do some work. Okay, I can call it from the main, and the nice thing is I don't have to repeat code. So I trip over my charger. So for example, I can do a cout, and then so I can have it right now. Obviously, it's not doing math, but it's going to print out hello. So I can call that multiple times. Oh, I'm getting your no. Get back. Cursor. I can't. Okay, I can't see. Sorry. Cursor disappeared. There it is. Oh, right. Oops. I'm gonna put it right here. So there's one thing that you have to know when you do this. Oops. So if you write a function, there's what's called the declaration, where you create it and you put the information, you know what it does. And then there's where you call it. For example, I'm calling it for main. If a declaration is below where you call it, it will not know what it's looking for. Okay? So for example, I'm going to use Do Math in my main. So my main is below where I actually create the function. Okay? So to give you an idea of what this code will do, I jump into my main, I call Do Math, I jump to Do Math, then I cout hello, and then line. Then I finish this function, I return to my main at the line I was at, I jump to the line below it, I call Do Math again, so I jump back into Do Math, I print out hello, and then I jump back into my main and I finish the program. So the easiest way to kind of learn to understand this is we have what's called a stack. Yes.
It says no returns taken.
Oh yeah. So this is an int. You can return 0, or you can make this void. Right here. If you want. You're good. You can also make this void Do Math. I'm going to leave it as int because I'm about to do something with it. The important thing to remember is this thing called a stack pointer, and you may have heard of. So have you guys heard of the website Stack Overflow for any programming questions? So Stack Overflow refers to a very common programming error with recursion, where you have your stack gets too filled up. So whenever you hear that, this is where this error comes from. We have what's called a call stack. So, and when we make a call to something, we put it on the stack with a pointer on how to get back. Okay? It'll tell us. So basically, let's say we start running main. We're on line 13. We jump into main. We get to line 14. We call Do Math. It remembers the line that we're on, line 14. Then it jumps over here to do something. So it'll jump back over here. It'll run the function. And then once it finishes, it'll jump back to line 14 where it was, and then jump to the next line. Okay? So for this is going to just do hello twice in a row. Like I said, it's going to do the main, call Do Math, finish that, go back to the main, call do math again. Yes.
Oh, we're just checking. So we always define our function before we call it.
Yeah. So if you flipped it, it'll probably say in your main cannot resolve function do math. And yeah, that's just because whenever you use functions, you just have to move them up. It's also generally good practice, even in languages that don't require this, to put the functions that are not that are used above the functions. Like if they're using the function, you put the one above it. So when you're scrolling through code, you'll be able to see that, and then so you always know you can always just scroll back up to find what you're looking for. Okay, so this will just give me hello twice on 2 different lines when it builds. So hello, 2 different lines. Really quick to show a little bit of different things. So I can also do things in the middle. I don't have to call the function. I can do it all at once. Sorry. So I can do like function calls in the middle. I can do other things. The important thing to remember is that, so this is not going to print hello, the number 100, then hello. The important thing to remember about functions is that you can always, they're basically to take a block of code you may need multiple times and then use it. So you don't have to type the same code. That's the goal, is to remove repetition. It also makes your code look cleaner, nicer. It's easier to document, easier to read. You know, there's a whole bunch of other perks, but just know that these have an incredible value, and you're going to definitely use them. So now I'm going to talk really quick about, so I put int here, and like I said, you said, oh, it has to return something. And so what this return means is so like I said with the stack pointer goes and runs through this code, and then it jumps back. When it jumps back, so return tells it to, when it jumps back, carry that value with it, okay? Whatever it returns, basically when you're writing code, you can imagine replacing it like that. So for example, I can say int x equals do math, and this is a valid statement, okay? So the reason for that is this returns 0. So when I call do math, whatever is returned at the end, you can basically imagine replacing it with where that function was. So in this case, do math just prints out hello, but then it returns 0. So my x will now be equal to 0, because when it returns out of the function, it takes that 0 with it. And so that's why I can assign x the value that comes from do math. Does that make sense? Returns are pretty important if they're not clear now. Just want to make sure. Okay. So for example, I'm gonna change my function up a little bit. I'm gonna call it now double it. So it's not going to print out hello anymore, but so now this function is great. The important thing to remember though is if I have a variable x in my main, I can't use it in this function, okay? That's because the scope of it is different. Main has its own scope of variables, and doublet has its own scope of variables. So if there's an integer x, for example, and let's make it 100, and then I tried to call double it. Right now, I can't use this x up here. I can't say x times 2. Okay, you're gonna get it's gonna say I don't know what x is. Can't resolve variable. So this is kind of to remember about scope. So, but sometimes you really need information. Like, double it, I want to double a value. I want to give it some information. So we call that passing. You pass a value, same way you pass a ball, pass the hot potato. So what we can do is we can pass in variables. There's a quick thing we need to change about the top part. So right now it's called int doublet. So that means it returns an integer, and the name is called doublet. And until now you've only seen these 2 parentheses and haven't seen anything in them. So this is kind of where it's going to change. So what I want to do is I want to pass in a variable. Okay. I'm going to call it number, or I'll call it num. Okay, so now this will give us a different error, which I can explain in a moment. So now the important thing to remember is in this scope, Now I'm going to have a new variable up here called number. And the value it's assigned to depends on what I call. So if I put in x, for example, in double it, if I put an x right here, it's going to take 100 with it when it goes to the function, double it. Okay? Then that int number, will now have the value that I gave it. So if obviously right now I'm returning 0. So let's double it. And return it. So what's happening is I have what happens is I have 100. I create this variable x with 100. Then I call double it, and I pass in 100. So over here, it creates a new variable called number in the scope, the local scope of the program, and then it's given the value x from before. So that this number now has the value 100. From here, I now do num equals num times 2. So I'm going to double it. I'm going to make it 200. Then I'm going to return num, which means I'm returning 200 now, because it was now 100 times 2. Yes.
Couldn't you just define x in the function above, and then you could save
When you say the function above, you mean?
Yeah, double it, like the one above. Yeah, that one.
Yeah. So I picked the name number. You can also pick the name x. You can actually change the name of variables. So this could still be x. That's fine too. Obviously, I'm going to have to change the name now below.
No, what if you just didn't define a variable and just put it as x?
Oh, without a type, you mean? Like this?
Yeah.
It doesn't know what type it is then.
Oh.
So, because what if maybe I want to do num equals num times 2, and I'm talking about a string. You can't multiply strings, so then it doesn't know. That's why it needs to be able to know the type of it, so when it can double check that the compiler can know if there's going to be a problem, basically. So I changed the name from number. You can always keep it the same if you'd like. I generally recommend naming variables something very helpful. For example, the letter x is not very helpful. You may have just seen it in math all the time, but it doesn't tell you a lot about the number. So I'm going to call it number here. So really quick to show off all this all at once. I have x. I'm going to step through what's called debug really quick. This is going to look a little scary at first. The cool thing about this is you can run line by line code. So let's say, whoops. So I'm going to really quickly, just tell me if you guys enjoy this, by the way. I don't usually run debug, but the cool thing is I can step line by line. All right, so what we're gonna do is, whoops, I cannot read that. So basically, this right now, this blue line is where our program is executing at, and I'm gonna step through it just one line at a time. Okay. So right now we haven't even started running the code yet. The line we're about to execute is int x equals 100. So we just execute this line of code, which means we create x and we give it the value 100. So this is our little variables list it comes with the debug. It's just kind of giving us a little bit of help. So now I'm going to call this x equals double it. So I'm passing in some function. I'm giving, I want to call function double it, and I'm giving it the value x. So it goes, okay, I need to evaluate this because I haven't done that yet. So it jumps up here. Remember, it passed in num. So num became 100, because remember, it was x before. It's now num. In our scope, it's now num, because remember, x doesn't exist in this scope. It exists in main, but it doesn't exist here. So we created a new variable number here. It's got the value 100. Now we're going to double it. So now it went from 100 to 200. We have num equals num times 2. Now we return num. So it says, okay, I got to go back to where I was. So it finishes this, and now it jumps back here. It finished doubling it, and it assigned it, okay? So it said this was 200, then it assigned x the value 200, and now it's about to print it, which I can pull up the console. I believe it's, where is it? I don't know where my console is. Oh, there it is. So and then we're good to go. Oops. Was that helpful? Not helpful? Less helpful? Ish? I think it's really cool to see the actual program run line by line, but let me know if that wasn't helpful. I will not.
How can I don't think I can like open it up on CLI, but I'm not sure how to
Open.
like
Oh, debug?
it line by line.
Don't worry about debug.
Okay.
It's purely for demonstration. Also, I'll make this bigger. I'm sorry, I didn't put it on view mode. Okay. Don't worry about debug. It's a really advanced tool that you're not going to know for a while. It comes in handy if you program a lot, but that was just to show you the line-by-line step execution. So really quickly, I'm going to do one other one, just showing off something else. So sometimes your program, you don't want it to return anything. You just want it to do something. For example, you may want it to print out some information to the console. You know, I don't need to return anything. You know what I mean? So I'm going to call this, I'm going to make a new one just called printNum. So all I want it to do is I want it to print out the number that I give it on its own line, okay? So this isn't, so the important thing to remember is the only thing I changed was this return type. So it's what's called void. If you've heard of the endless void of space, that's where the naming scheme comes. It means empty or absent, no return. So instead of returning, with a number, for example, I returned 0 before, then in doublet I returned the number I got in by 2. This doesn't return anything. It does what I need it to do. So when it goes back, it doesn't bring anything with it. Okay. So for example, if I wanted to call this again, let's call printNum. Let's pass in x. Let's make it something like 42. We'll run it. So we can get 42 straight out. So, whoops. As for program execution, just remember I created 42. I call printNum with x. It creates that local variable num, gives it the value, with value 42 from what it was passed in. Then it prints out number, and then it jumps back out to the main. Are we good on that? This is making sense? Okay, we're going to do a couple really quick programming, like kind of getting a feel for this. So, oh wait, sorry, I need to show one more thing. Okay, so you can pass in one variable, you can also do multiple. It's not just a couple. So let's say I want to create, something that gets me the sum. So I want it to give me the sum of 3 values, for example. So int y, int z. So the difference about this one is that I'm going to show off a couple of things actually. So here we go, x, y. So you can do a couple of things with this to be a little bit faster. So the most important thing to know is you can do multiple parameters. The important thing to note is how they're defined. So before it was just the singular. It's always given as a type, the type, and then the name. Okay, and this is important because again, like I said, it needs to know what type it is when it's starting, just to make sure it can do all the things you're telling it can do. So in this one, I created x for 42, y for 64, and z for 15. And then I'm calling this function called sum, and I'm passing in x and y and z in that order. So that means when I create another x, y, and z up here, it gives this one 42, this one 64, and this one 15. Then I'm returning x plus y plus z. So basically, you can on the return line itself, you can do math. A return has the lowest precedence of any operation, meaning any expression here will be evaluated automatically before you return it. It's looking for a singular number or a singular answer to give you. So I'm also going to show off one more thing. So right now I'm returning x, y, and z, but at the moment it's not going to do anything with it. Okay, this is called, I call it dropping it on the floor. Because here's what's happening in your code, and this is, so I call this function sum with x, y, and z. I pass in x, y, and z. I say great, compute x plus y plus z. Let's say it's 100 because that's not right, but whatever. It's a little bit bigger than that. once it creates that number, it says return it. So it goes over here and it says, great, here, whatever, this is replaceable with the number 100. So imagine just a numerical 100 there, and then a semicolon. And then your program ends. So generally you want to see the value, like the output of this function. So there's a few different ways you can do that, but just remember that when you return something, imagine replacing what that function call is with the answer that it gets out of it. Okay, it's a really important concept. So to really quickly reiterate, basically I'm going to call sum xyz and nothing prints out, even though I called this sum, because it returns into nothing. It didn't actually put it somewhere. So I want to see it. So there's two different things I can do. I can just see out it, just straight up, and I'll get the answer. So 121. Because this time now when I compute 121, I return it. I'm returning it. So remember, I replace sum with 121, and then I see out 121. So that's how I can get it to the console. More commonly, you probably want to do something with this. So let's make an integer called the answer, and that's where this this equals is. So I compute the 121, replace it, and then it's int answer equals 121, and that's how I get that assignment. Okay. So just be careful with returns and making sure that when you call a function, if it has a return, you generally want to take advantage of it. And then, so now a general progression of questions is what does main return if it has an integer? So main returns what's called an error code generally, or a code for how your program is running. So for example, main returns 0 unless something happens otherwise. Okay. So it says process finished with exit code 0. That's what my main returns. You can change this to 42, return 42 at the end of your main, it'll return 42. You generally don't want to do this though. Okay, generally return 0 in your main, because that tells you it got to the end of the program, and it ran.
Is it better to write answer, like to find the answer sum equals xyz, or write cout?
You you mean like cout answer?
Yeah.
Generally, if all your goal is to print it out, just print out the sum in one shot. I'm assuming I'm probably going to use this answer somewhere else. So you generally want to keep it. Most times in more advanced programs, you don't really print out anything. There's usually, you're passing it to a GUI kind of to do stuff with, or you may be doing like, you may be GUI, you may be doing work on something else. So like you're maybe returning values to like, you're like topologically sorting information. And like, so then like what you get out of it maybe is like some ordering, and it gives you like, oh, this took, there are 52 items on the list, for example. You generally don't need to print out 52 to the console because the user doesn't see the console. It's helpful for you maybe as a programmer, but you generally want to keep it with an answer. As for the int answer equals sum, if your goal is just to print out the answer, you don't have to create a variable. That's kind of an extra step of creating that variable, because it'll just replace sum on that line with whatever answer it gets out of the function. So really quick, I want to, again, iterate this. I'm going to say this another 3 times, because this is the best, I found this is the very best way to understand functions. Whatever you pass in, it'll do something. When it has a return, just replace whatever comes out of this right there. So for example, it's 121. So this line becomes this line below, okay? Ignore the red for this. It runs the sum. At the end of sum, it does that. This is the actual underlying code that will run, okay? Just to be very clear. Important concepts. How to not screw this up, okay? So I'm going to do really quick. Did you get Xcode installed? Okay, you have internet, I'm guessing then. Yeah, okay. So really quick, we're going to do a couple of practice, kind of writing a couple functions. So this first one, so I'm gonna give you this definition for it. So I'm going to say I want no return type, no return, don't return anything, so void. I want you to name it. I want you to name it product, and I want you to take in 2 numbers, and then I want you to print out what they are multiplied by each other. So you can name them x and y, q and z, num1 and num2. But obviously define a function no return type, call it product, and take in 2 integer values. Okay? We'll just do that part first. You don't have to write the body yet. It'll be 1 line, but don't have to write that yet. Just the title.
Can you put any values for the 2 numbers?
Nope. Just the important part is to get this part right here. Okay, so here's how I do it. So if you guys got this? Good. Okay, now I want 1 line in the code. I want you to print out to the console, so C out, and then the insertion operator. X times y. Multiply the 2 and print it out to the console.
Can we remove the void?
You mean like entirely if it doesn't return anything?
Yeah.
No, you have to specify.
But can we put in instead?
Oh yeah, we're gonna get to that in a moment. There's gonna be a few of these. I really want to focus on the subject since we're a little bit ahead on the course content. I want to be extra clear that this is a good thing to be good at. Okay, I promise you. Write a whole bunch of these if you write code a lot. So, okay, so we got this. So really quick, printing out the product. I said C out. I wanted X times Y. Just like that. Okay, now in the main, call it. So I want you to call it, pass in the numbers 13 and 10. So that. Thumbs up. Good. It works. Okay, so sorry. Once you do that, run your code. Call the call product, pass the numbers 13 and 10, then call product. Binary not found?
No, it says like.
Oh, you want to name it? Oh, you're good. You can just finish. You don't need to prefixes. Oh, did you guys want an explanation for that, by the way, what those cross compiler prefixes are? Did you guys have you guys run into that where it says that when you're creating a project? Like at the very end when you're making a new one, you're hitting finish repeatedly because you want it to go away. Not in C-Line. C-Line doesn't do that, but in Eclipse, no? You've never seen it? Okay. I'll ignore that. It's complicated. It's for running a program. You can run like some other stuff. Super high level again. Even I don't know all the prefixes and things like that. That's something I still need to learn. We good? Called it with 13 and 10. So okay, so this is what we're gonna get. Looks just like this. Product 13 and 10. So what will this code do? You can say it in one line. I guess still working? There you go. Okay.
No.
So basically it prints 130, but how come it prints it without us writing C out? Is it because like we already wrote the C out?
We have a C out right here in this program. So your output stream is this kind of like, it exists. You can access it from anywhere, as long as you use C out, of course.
So it doesn't matter what order we write it in.
The
It
code.
doesn't matter if we put it in the main order.
The C outs?
Yeah.
No, yeah, it doesn't matter. Actually, there's other things. So you can actually replace C out. You can create a file, like an actual text file, and then you can replace, instead of C out, you can go to the text file, and you can send text to it. I'm not going to cover that because there's a whole bunch of errors and a whole bunch of debug problems that a lot of college students couldn't figure out in 3 hours. So that's an entire week of classes that I'd rather not go into. But yeah, so this is something you can output to all the time. It kind of exists with your program. It's kind of attached to it at all times. Imagine like a straw, kind of just like poked in when you run the program, so then you can always send to it anywhere from it. Okay, so we got 130 printed out to the console. Really quick running through how to do it. We jump into our main to start the program. We call product with 13 and 10. So we jump up to product. There's an X and a Y. Replace X with 13, Y with 10. Or I should say, we could say assign it. Assign X to 13, Y and 10. Then we do C out, X times Y. So that's 13 times 10. So we printed out 130. We finish this function. We jump back to the main. There's no more things left in the main, so we're done. Okay? Makes sense? Okay. Okay, so we're going to do, again, this is going to be one with a return type. We're going to do, are you guys all using namespace, standard namespace? We're going to do a string return type. We're going to call the function plural, P-L-U-R-A-L, like plural. And we're going to pass in as a singular argument, that's what these are called, parameters or arguments, a singular string. You can call it whatever you want. Okay? So string return type, call it plural, pass in a singular string as well. Okay, are we good? You got that? Create this string called plural? Cover my answer so everyone's good? Yes? Just let me know, okay? We're good? Or any questions, I should say. Or if this is going too fast, definitely ask. Are we good? Got that one? Made sense? Plural? So it looks just like this. If you're using the standard namespace, just make sure you have this line right up here on line 4. If it's not recognizing strings specifically. But here's my function, string return type, name is plural, singular argument called string, or a single parameter called string. That's of type string, sorry. I called mine str, which is like shorthand for string. So now what I wanted to do, I want you to return the string that you're given, and then add the singular string letter S to it on the end. Okay? So return the input that you get, and then also add the letter S to it. So you can add two strings, just do a plus sign and then a string, okay, with the letter S. Throw this out. Are we good? Ready to go? Next step? Thumbs up, thumbs down? Not sure? Still working? Good? 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 You got it? Okay. So, I wanted to return a string. So I wanted to return the string that I was given. Plus, I wanted to give it just an S at the end. Just like that. So this is returning the string plus the letter S attached to it. Alright, so in the main, we're going to call it. We're going to pick some singular word. You know, I don't really, like for example, like raccoon. Or something where adding an S would make it plural. Okay? I'm going to use, I don't know what I'll use. I'm going to call, but just basically call plural from your main, pass in some singular word, and then watch it become plural. Let's probably change that. We good? Making sense so far? We're still typing? Got it? Kind of? Close? Did it work? Got it?
Oh, I don't have a CL.
Good. I'm glad you noticed. I was hoping someone would say something. Alright, so because it was mentioned, what does this program print out?
Nothing.
Nothing. So remember, why does it print out nothing? This program does stuff, but it doesn't tell us anything. Why not?
Does it have any output comment?
Yeah, we do this, we calculate plural. We use plural, we pass in penguin, and we do stuff to it, and then we return it, and then it goes nowhere. Remember, we replace plural penguin with the output, which just adds an S to it, so then it gives us penguins, and then nothing happens. So, I'm gonna add my cout, because I want to see the answer, and we're gonna get penguins. Did that make sense? We're good? I know we're going the same concept a few times. Okay, are we feeling like that made sense now? Okay, so this is where it's going to get a little harder. Okay, I'm going to preface this with a warning. So, it's kind of cool to return things and all. So C++ is a very powerful, but again, very problematic core part of the programming language. So from before, let's say I wanted to create a string called the answer. And I wanted to assign it what I get, okay? So this says the string answer equals whatever comes out of plural. And so what I have to do is I have to copy, I have these penguins. I have to create another variable called string1. I have to copy the information from wherever it started to here. I have to do something to it. Then I have to return it back to where it was, then copy it again. And that's a lot of copies, So we have this thing called passing by value and passing by reference. Okay? So the most important thing to remember, I'm going to use this whiteboard real quick, is when we talk about those boxes where variables were. I have an eraser. Okay, so the important thing to remember is, ignoring this terrible business plan, is to remember when we create a variable. Oh, I'll spin this out. The important thing to remember is when we create a variable, we give it this little box, and it comes with a name, so I can identify it from some other variable. So remember how we said this has some memory location? It exists in your memory as in the larger block of memory. It's maybe right here. This is X. So it's really important to understand this concept, right? Because this is where it's going to get hard. You're going to spend a lot of time on this exact problem. So it has a name, X. We're going to store some variable in it. Okay? So imagine this has this value 100, let's this is 100. So there's some information in your memory that takes up this location that stores the value 100. Okay? So when we pass by value over there, for example, what happens is we go to the call. We're going to call that function, and it says, "Great, create that value." So maybe we'll create a new value. We copy the information from this. We'll call this Q for now. So in my function, maybe it's called Q. I have to copy the information from here to here, and then this is identical, and then I do stuff on it, and then I say great, then I return it. So then it goes your actual variable that you're using in your main is down here. So what it does is it copies the value up here. So your variable in main is X, right? And then you call it. Where is this actually? This will make it too complicated. So this is your variable X in your main, and then you use the function. It does Q. I had to copy it. It does some math on it. Then it returns it. Says great. Reassign it back here. And that was a couple extra steps that you actually don't have to do. But the important thing to know is that was called a call by value. What happens was I needed the value itself. Okay? So if it was a string, I need the actual string. If it was a number, I need the numbers. So we're going to learn about reference. So references are kind of like your library. When you think about a reference to something. So what a reference is imagine books at your library. And so instead of copying a book, because in this example, what I did was I had my book, I made a whole other copy of it, I changed it, and then I handed it back and had to replace the book I had originally, just to make a change. Wouldn't it be better if I just handed my friend my book and then he made the edit and then gave it back to me? Does that make sense? I know what happened? Instead of him copying the book, making a change, and then replacing my book, instead I'm just going to give him my book in the first place. Okay? This is clear, yes? Understand? Okay, cool. This is really important because this is gonna be like a week or two of content that we're gonna go over. So you can actually give this value and say, here you go. You don't have to copy it. Just have the value. Make some edits to it on your own. So what happens is you give it the reference. So I'll show it in the code. Basically, you say, here's this location. Remember, it's that location memory. And instead of giving it the value, that numerical value, that string, you give it the location of memory and say, here you go. Go do with it what you please. And so any changes you make in that function will affect this value, even if it's not in the scope of your function, because it has the location to it. It's kind of like you can break into any house if you have the exact address. Okay? There's no protection, no lock on the door. When you copy it, you make a whole other fake house to go do things with. Okay? So that's what call by reference is. And this is going to be introduction to what's called pointers and a few other things, but the important thing to remember is things that are variables have a location in memory. And you usually refer to them by name, but they can also be referred to by address in memory. Okay? Okay, so I'm gonna, whoops, please come back. So I'm gonna show off how this works. So remember before I had to return it and do things with it? We're gonna basically do this in a little bit faster. So I'm gonna change this to my doublet again. So we're just going to go back to my doublet. So here's the important thing. Remember, this is going to be a void. Okay. So let's make a variable x equals 100. Okay. So the important thing to note the difference. I've got this singular ampersand here. Okay. So whenever you see this ampersand, you want to imagine this as reference to, okay, in English. Reference to. So the way this would read is I'm talking about the void. This function is a void. It returns nothing. It's called doublet, and I pass in a reference to an integer value that I will call x. Okay? So the cool thing about this is notice how there's no return type. It's not going to return anything, but as you're going to see, I'm actually going to be able to change this value on its own, okay? So, as you can see, this is now 200. I didn't even return anything. I didn't assign x anything. All I did was I gave x as an address and a location, okay? Notice how I didn't change anything here. All I did was say, instead of by value, I now want to pass a reference. Meaning, nope, don't copy it, don't make a new variable and copy it. Keep that same box. So I'm going to really quickly run over this, and I'm going to grab a piece of paper real quick to solve.
Tissues are there.
There's also a paper towel. Is any of this not clear so far, though? Very clear, understand, kind of, makes sense? Or at least you're getting a little bit of the hang of it? Okay, so. Here's how this program runs, and this is why it changes it, and I'm going to write another program that isn't going to do that, and I'll show you the difference, okay? Did I put the pen? That was in the pocket. Okay, so. This is the by reference one, okay? This is going to be the new and improved one, and I'll do the old one more time just to be very clear. So, you got your memory block, right? This exists over here. So, in my program, I create this variable x, I give it the value 100. Okay? Name it x, give it the value 100. Right? Understandable? It exists right here somewhere. So, I'll show you what this is. This actually is something associated with this to find out what it is. So, but it's 100 for now. Okay? So then I call doublet on x, and I say I want to pass the reference. So instead of handing it the value, I hand it this location right here. Okay? I say, here you go, have this in my function, which I'll put down here. So it says, great, do x times 2. So when I do x times 2, it's that when the function looks for it, I'm doing x times 2. Instead of going to look for the copy, it goes back to the original location to find it. And it says, great, this was 100. And I remember I assigned x that value. So x equals x times 2 says, do x times 2, which means go to this reference, find x, multiply by 2, it's 200. Now assign the variable that's at that reference, the value from here. So x equals 100 times 2, x equals 200. So now it goes back here. Remember, that's right here. This is what that number that's stored there. And it says, great, assign this 200. There was never a return. Okay, all I did was use its address to do math. Okay? So now I'm going to change the code a little bit. I'm going to show a different one without the reference, okay? I'm just going to change this and watch as the number goes from 200 to 100. Okay? So now I'm going to explain what happens here and the difference, okay? So, this was program 1. Now we're going to do program 2. Do you want me to leave this up here and do it right next to it so you can see the difference? That help? Okay. So we have X again. We're creating this. We have our program stack right here. Our call stack. It's going to be our little memory block. So we create X with the value 100. Then, so it exists right here. We'll give it, this is our X. So then we call doublet X. And it's not by reference, so we're giving it a value. So it's calling a value. So then somewhere over here, it says, great, create a variable. It's unfortunately also called X, but that's okay. So we create this other X, that's over here. We give it the value 100. Remember, this is the copy from before. Now we're doing X equals X times 2 in the local scope, which is the scope of that function. So we're talking about this X, not the one that's not in scope right now. Now we do X equals 100 times 2, X equals 200, so we replace this with 200. Then our function ends, so we jump back to our main, so all this disappears, okay? Because the function ended. Any variables I created in the function now disappear. And we go back and we print out X after calling it, and it's still 100, we never changed it. We only edited some other X in the function, okay? Was there anything unclear about how there was a difference there? What happened? Are we good? That kind of makes sense? A little bit? And then, okay.
So that symbol basically just gives you the address of the...
Yes, it gives you an address. So remember, there's copying my book, literally creating a whole copy of my book, doing something on it.
Which is return.
Yeah. So, for example, what happened in this program right here was, I had my book, then my friend made a copy of my book, he made some adjustments to his book, and then I asked to print my book. Again, out of that function. I never asked for his book, or even to get the answers from his book. You know, what did he change in his book? I don't know. Because I didn't return anything, and he didn't write in my book. He used his own book. Whole separate variable, whole different set of math. Up here, the reference, I said, I have my book, take my book and make a change to it. He makes a change to it, and then I can get my book back and see the changes. And that's why I get 200 printed out here and 100 there. Okay? Good? There's going to be a whole other week of pointers and things like that. They're this kind of weird. Okay? So that's understandable? Okay. Cool. Whoops. All right. So we're going to do a couple really quick other thing. Make sure to highlight this. We're coming back to this. Okay? It's coming back. It's going to haunt you for years if you program in C++ forever, like me. This will haunt you. Make sure there's going to be like one more problem with this. Maybe two, as soon as I think of the second one. But this is going to be the homework, basically, is to go try this out a little bit, get the feeling of what a pass-by value and a pass-by reference is. Okay, actually, I do want to demonstrate one other quick thing. So, I use that ampersand, and the important thing to know is what does that do? What does that look like? So you can actually call cout on it. So I can call cout on that ampersand, okay? So you're going to see a number that sure isn't 100, okay? It's going to probably be 6 to 8 numbers. It's going to be pretty random. 0x61ff1c. Does that look like 100 to you? Because it sure doesn't to me.
That's the address?
That is the address in memory. in RAM. So if you want to know what this looks like, it looks a lot like you've probably seen colors before referred to in this way with 0xFF up to hexadecimal. So this is a hexadecimal number. I couldn't tell you how big it is because I can't do that conversion in my head very quickly. So this is just some address in memory Windows gave your program when you ran it. And I just asked for it. I said, what's the actual address? So when you pass by reference, instead of passing 100, that's what you get right there. Okay? Is it clear on that? Kind of makes sense? Reference, value, two different things? Okay. Okay, so we're gonna definitely just remember we're coming back to that. So we're gonna do really quick thing called overloading. So we're gonna recreate that sum function from before. We're gonna give it an integer return type. And we're gonna pass it two values, int x and int y. Okay? We want to return x plus y. So there's this thing we can do called overloading functions. All right, this is gonna be a little bit weird. It's great to compute sums of two numbers, but what about sums of three numbers? Or maybe I want to do maybe even better. I kind of want this to do floats. Maybe I want to do doubles. I want to be able to add two double values. So what I can do is I can actually do this. So I'm gonna do double sum double y. Okay? So one thing I want you to try first before you put this line of code right here, keep the name int. Try to copy paste this method. Okay? Keep another int sum, copy paste it, change the variables from x and y to z and q, or two other letters. Okay? Before you add this right there. Okay? Okay, so you're going to get a nice little error. It's going to pop right up on sum. And it's going to say there's already a declaration of a function called sum. And you go, man, that's stupid. So the weird thing is, I wrote this function down here. What's different about this one?
Different type.
Different type? Okay, so what if I made this an int as well?
We're defining the same thing twice.
So what's the difference between the one? So we're focusing on this top line where I talk about the function. What's the difference between this and the one below it? The int sum xy and int sum xy. What's the difference? Anyone? Difference between these two? Just you don't have to look at the return type. Just this first part. Int sum xy, int sum xy. What is the difference between the two? No? Okay, so, the difference is the type. The type of the values I'm passing in, okay? So this is an int x and an int y. This is a double x and a double y. Even though the function's name is the same, we can do this because we're passing in different types, okay? When it says duplicate declaration, here's what it will look for. It's looking for the same type, the same name, and the same returns. Okay? It's looking for those to be the same. So here's an example of one that won't work. I could do like double sum. Oops. So why does this throw an error? So I'll tell you right now, it's going to give me a duplicate declaration of the thing I just talked about above it. So
you're defining the function using a different type of, like when you're, I forgot what it's called, but inside the parentheses, you can change the types.
yeah, so the reason why this is a duplicate is because all I did was change the return type. Okay? The important thing to remember is I can make a distinction between these two. If I give you two integer values, I know to use this one. Okay? If I give you two doubles, do I return an int or a double? I can't definitively tell you which one I should return. Okay? So that's why it throws an error. Now I'm going to change it up one more time. I'm going to make this an int. And this one isn't a repeat. Because before I can do int. This time I have double. Now I can do int double. Okay, and this isn't a repeat because again it can tell that if I pass the first number in that is an int and the second number is a double, I know exactly which of these three I need to use. Okay, that makes sense. So the important thing to note is that the type they have their ordering matters as well as their types. So this is also a unique function. Okay. So this is not a repeat of the other one. Because when you pass values into a function, the order matters. Okay? This first one, I passed in an integer first and then a double second. On the second one, I pass a double first and an integer second. Because I know the order of the parameters, I can give you a very definitive answer. If you said, here's 3 and 6.8, I want to use this one right here. There's no other one that'll fit. Only one. If I give you 6.8 and then 3, I know exactly which one to get. It's this one. It's the moment where, as a computer, I couldn't make a definitive guess. I can't make a guess. I have to be sure as a computer. When I don't know for sure, that's when you usually will get an error in code. Okay? So that's why changing only the return type would say duplicate function declaration. The name and the values it pass in are exactly the same. In the exact same order for them, so it can't tell which one is which. So to show off a little bit of this, so I've got I'm going to delete these other couple really quick. So I've got a double. I'm going to make this a double return type now. So the cool thing is that I can go down to my main and I can say int x equals sum 5, 10, and I can do int y equals sum 6.2, 3.8. Or I should probably make this a double, sorry. So now I can I can call the same function, it's got the same name, all I did was change the integers to doubles, and it'll still work, okay? Okay. I'll just happen to add exactly to 10. I'll fix that. There we go. 9.9. All right. Was there anything question? This is called the function overload because the name is the same and the types are different. Okay. Same name, return type doesn't matter in a function overloading. Same name, different values passed in. Still works. Okay. Is this clear? Makes sense? We're good on this? Okay. We are going to really quickly do this one. We're going to do a couple of these really quick. So I'm gonna make my own function really quick, and I want you to make a few of these exact function. So I'm going to create a function and make it void. I'm going to call it callback because we were talking about that earlier. So make one that has like this. It'll have no parameters passed in. Okay. Once you have that, I want you to pass in an integer I want you to make another one, same name, just pass in an integer. And then another one after that takes a string, okay? So make a callback with a default, no return, default, it has no parameters passed in. Then I want you to create 2 more callbacks, this time one that takes an integer as a parameter, and then another that takes a string as a parameter. So 2 extra functions to write, okay? We got that? Still typing? Still working? Good? Not good?
We have 15 more minutes.
Yeah, I'm typing this up now. I'm part of it. Are we good on that? On the callback? So, really quick, this is what it'll look like. So I said I wanted a callback with an integer. So here's my callback with an integer. And then here's my callback with a string. Okay? You guys get that? Thumbs up, thumbs down. Not making a lot of sense, kind of weird. Feedback appreciated. All right.
Yeah, I'm just worried that kids are gonna run over it. That's my main concern.
Okay. Are we feeling good, Deb, on this? We're gonna combine these, okay? So I'm gonna really quickly show off part of the homework. So just to keep this a little bit clear. So I'm just gonna show. So I'm gonna call this functiony. So here's your question. So I have this function that takes x, y, and z. Now I have this other function. I'm overloading it. And I'm going to give it x, y, and I'm about to give it z, but as a reference. So before I type this, whoops, I missed the comma. Well, is this going to say this is a duplicate function? So right now it has 3 integers. I'm going to give it 2 integers by value and 1 by reference. Will this be the same or will it be different? I'll let you think about it for a couple seconds. All right, here we go. And Z. Is it different? Am I getting my nice little red arrow? All right, so passing by value and passing by reference. One little part that's slightly different. So what type, I printed up that reference before, right? That nice little hexadecimal number. And remember, the function doesn't know, when I pass a reference, I tell the compiler that it's an integer, but I give it a location. Does it actually know this is an integer? Does it know what's stored here is an integer? Not really. Okay, it's like saying, here's a location. I'm going to give you a street. How about 562 South 84th Street? What's there? You don't know, really. And then I say, oh, a business is there. You just kind of have to take my word for it. Okay? So I say it's an integer, but I'm passing you an address. That isn't an integer value, but I'm telling you what's there is an integer. So the compiler says I'll take your word for it, okay? But it doesn't know for sure. This is a different, when it comes to making a function, this is different than that, okay? This may be a little confusing. A reference, you can do integer stuff on it when you're using it, but in the declaration it doesn't know. This is just some number that you hope is an integer, and you tell it is an integer. Okay, is that clear? Okay. So this is a preface to the homework, actually. If you want, this is kind of where I want to stop for today. So we got a couple extra minutes. Basically, what I want to do is you're going to create this function. You don't have to call it functiony, or you can, I guess. I'm not too picky. I basically want you to create this. Don't pass. Create one that passes Z by reference, just Z, and then I want you to create one that passes it all by value. So like this. So create one more really quick. Name it functiony again. Pass all three by reference. Okay. You got that? One more name, functiony. Feeling good? No? Yes? Maybe? Okay. So, I'm going to go over the next little part real quick. So remember, we have one all by value. We have with two by value and one by reference. And then we have all three by reference. Okay? So now I'm going to give you three numbers. And basically, you're going to run this code and see what happens. Okay, and how it changes. So I'm going to fill in the code for you in a moment, but here's what you want. Create a variable called A, B, and C. And we're going to give 56. I know a favorite number? Favorite number? Anyone?
42.
42? Okay. Okay, so here's your three numbers. Now, we're going to do really quick. I want you to print out the references to all three. Exactly like this, by the way. So So basically just take this line down. This is going to print out the references with spaces of A, B, and C. Pay attention to what these are, okay, when you run your code. Pay attention. You can mainly focus on A, but don't, look at B and C as well, okay? Look at the hexadecimal number it'll be between every time you run your code, okay? That's the first part of this. Now, you should have a function up here, functioning. Remember, you're passing some by reference, some not. So, in our functioning, the code is going to be exactly the same. Okay, so this code right here is going to go in all three. This exact code right here. You can copy and paste it all 3 times. There's going to be, of course, that other function. Remember, that one's passed all by reference, all 3. You can paste that same code. You can add a return -1 at the end of all your functions. Or you can make them void. I'm not going to use returns for now. So, we're just going to call it and we're going to get ambiguous call. Whoops. Okay. So, really quick. Why is this ambiguous? Okay. Why is this ambiguous? So ambiguous means like not really sure. Okay? So why is functioning, when I was able to create multiple, why am I having a problem now calling it? When there's one that calls all by value, one that calls with just one by reference, and one that calls all 3 reference. Why is it ambiguous? Okay, I'll let you think about that for a moment. Okay. Now, you can go ahead and delete this really. While you think about that, you can delete this function right here. That's all passed by value. So, and you should have one with one pass by reference, and then one with all 3, right? You have 2 functions now. One with z pass by reference, and then one with all 3. Scroll down again. I don't have the 3rd function. What does it say for functioning? Running out of time. What does it say for functioning? Does it give you an error still? You got the 2 functions, 2 calls to 2 different functionings. They're overloaded. Is there still an error on the line functioning? Does it say call to functioning is ambiguous? I don't know if it may be on Mac, but so you're still going to get an error. And the reason for that is, remember when I called by reference and I called by value, I put the same thing in there both times. I said, here's 3 integer values. So above, I had an int functioning that called by reference, and values, and then all that by reference. And I told the compiler, trust me, I know what I'm doing. However, when I pass values in, if I wanted to pass by value, so let's say I want to pass only C by reference. That's what it would look like. If I wanted to pass them all by reference, here's what it would look like. Okay? So remember, when we called by reference, we didn't change what the function call looked like. We only changed what the function did. Okay? So remember what I said about how your code, when your code runs, it needs to be able to know definitively what to do next. So call to blank is ambiguous because it doesn't know. Do I pass only C by reference or do I pass all of them? It's not sure, so it won't let you run your code. Okay? So that was just to kind of make a point really quick about that. I'm sorry to make you type some extra work on the fly. Keep the one that passes only Z by reference now. You can delete the other one. That passes all 3 by reference. So you should only get this one now. Only one function. Make sure it's just like this. Scroll down. Okay. So make a call to functiony. And then what you want to do is you want to print out all these values again. Okay? Except not their references. Okay? So this is all your homework. Really quick. I'll scroll up to make sure it's... Okay. Are we clear? Good? There's just going to be a run some code homework. We have functiony. It returns an int.
Can you scroll
Up here. Sorry. I'm going to just talk about this. You can ignore that part. So it's just going to take 2 values by number, 1 value by reference. Sorry, 2 values by value, 2 variables by value, 1 by reference. It's going to do exactly this. Here's your values. You're going to run it once. You're going to print out what comes out. Okay? What you're going to do, run it with these values. Tell me what you get. Then create your own set of values. Pay attention to what these are. Okay? So basically, you want to write out on your piece of paper or somewhere what these references are, what the hexadecimal number is. Change these numbers, run it again, watch what these are, these 3 numbers again, and see how your function behaves, okay? That's your homework assignment, and with that we are over time, so I'm sorry. Is there any question about the homework really quick?